morning, sir. No, sir.
Okay, so yesterday we were done with the chapter ray optics, so we will begin a new chapter today. Okay, I will not tell you the chapter. As I demonstrate and show you the slides, we will figure out what is the name of the chapter and theme. Okay, so like I said before, this is a science week. So first of all, I will begin with the quote. Okay. So this quote is related to our topic. Please focus on what the quote is saying, and after that I will show you a demonstration. I have brought some tuning fork and some wires, some beaker and a glass. So I will show you a demonstration. I will walk around. Please observe what is happening, and then we will look at the different types of waves and their characteristics. Okay. So let us begin with the quote. Can you please read this quote?
This entire universe is nothing but vibrations. It is all made up of waves, vibrations, and energy. When your vibrations do not match with the vibrations of others, you call it negative. And when your vibrations match with other vibrations, it is harmonious and you call it peace.
So, what did you understand from this quote? Just give a bottom vibration. Okay, like not don't just focus in physics. Generally, what did you learn?
Waves.
Okay, so what is the quote trying to tell you? Yes.
So when our the vibration,
Can you give my answer?
so the vibration can be like a metaphor for like our vibes, and when the vibes of our and another doesn't match, then the vibes is like a negative. That means we don't match. While the vibes, if our vibes are like similar, that means our vibes match, and then we call it bliss.
Okay, good answer. Thank you. So you all are in the classroom, but you still have your best friend in your class, right? A friend with whom you can hang out with, right? So the word vibe was popular because this is the short form for vibration. Okay, it's just not a metaphor, but the short form of vibration. The Gen Z people call it vibe. Okay, so you have learned about good vibes and bad vibes, right? Not the restaurant good vibe. Okay, the good vibes. So these are called vibrations. So anything that surrounds our universe is all due to vibration. Okay? And in physics also, everything is connected with vibration. So we will learn about vibration and something related to vibration. Okay? And I will show you the demonstration. We have another quote that I saw in the science corner. I don't know who pasted this. Anyone from this class? No? Can you read this also?
If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration.
So here also Nikola Tesla, it is said by Nikola Tesla, and he is talking about vibration, right? Energy, frequency, and vibration. So all the answers of the universe, it lies in the vibration. Okay. So now we will see what is that. So in that case, I bought this. You must have seen in the physics lab, right? What is this?
Tuning fork.
And what is this one? Plastic. It is a rubber pad, okay? This is where we strike this tuning fork, okay? You can't hit on the table because this will damage the tuning fork. Therefore, we have a rubber pad because it is soft and durable, so you can hit it very easily, okay? And you can produce a good sound when we hit the rubber pad. So, I will show you one demonstration. Maybe I can do it here. So I will struck this rubber pad and I will keep this tuning fork here. Just hear or observe what is happening, okay? Observe? This was a small tuning fork. Now I will use a bigger tuning fork, okay? You all heard? Yes? The one from the back. Are you able to hear?
Yes, sir.
Now I'll be using beaker. I will walk around. This may not be. Some may not be able to see you. I mean, do you all observe? No. Okay. I'll be walking around. Are you able to see? I will here. Sorry. In this two demonstration, while I did on the thermocol and the beaker, what did you all observe? So for that, can you look at the figures here? What are these things? What is the first one?
Water wave,
Water wave. Second one is
water drop wave,
water droplets. Okay. Do you
Sound
know about
wave.
this? No? Anyone? Okay, I will get back to this. And what do you think is the last one?
sound wave,
Sound waves. Okay. So for that, I already showed you the demonstration. Now there is something called as think, pair, and share. So what I want you to do is pair with your shoulder partner. I think everyone has a shoulder partner. Now can you discuss the two demonstration I showed you and discuss what was happening for around 3 minutes? Can you start discussing with your partner right next to you or shoulder partner? Then anyone can volunteer or I will ask a roll number, okay? Okay, done everyone? There is nothing special, okay? You have seen what was happening. I showed you the thermocol, right? When I was hitting this rubber pad, a sound was produced, right? So discuss why do you think it was happening, what was happening. When I dipped in the beaker, what did you notice? You can say anything you like, okay? My time flies faster, okay? 10 seconds, 5 seconds, okay, stop. Any volunteer first? Yes, Captain?
The vibration does not last long in the water, and compared to the thermocol
Yes, thermocol.
square regular thing, it lasts longer than compared to water.
Okay, it was lasting. Okay, good answer. Thank you. It was lasting longer. Anything? Any different answer? Yes.
So what I observed was that when I said ignite with the thermocol and water and the vibration is transferred from the thermocol, from the tuning fork to the thermocol and the water and it produces waves and sound.
It produces waves and sound. Okay, good answer. Thank you. Waves and sound. Any more volunteer? Three? You wanted to? You raise your hand. Same. Okay. Any different answer? So when I struck the tuning fork at the rubber pad, what was happening to the tuning fork? Vibrating. Okay. Can you tell me another name for vibrating?
Oscillation.
Oscillation is a bigger word. We will get back to this later on.
Moving back and forth.
Moving back and forth. Okay, back and forth. These are your answers. Okay. So when I dipped the tuning fork after striking in the rubber pad, what was happening to the water? Splashing. And what do you call this one? There is a specific word for this. That phenomenon is called? It's called ripple, okay? So what was I doing to the water? Okay, it's a vibration, but general word, like English word, not don't just go to physics. Yes. So let's say you are studying in the library and someone shouts at you or disturbs. Okay. Noun form of disturb is disturbance. Okay. So there was a disturbance in the water. Okay. Disturbance. So I was looking for the word disturbance. Okay, or disturb. So I was disturbing the water, right? And when I disturbed the water, it formed a ripple, and that ripple is called wave. So you know what is waves now? So we will be talking about waves. Okay, so our new chapter is called as waves. Now, any volunteer, how do you define waves? Now I have said the definition. So can you form a sentence now? Waves. I have used the word disturbance also. Now use the word disturbance in a sentence, and can you tell me the definition of waves? Okay, roll number 17. It's okay, don't worry about getting the wrong answer, just tell me whatever you think.
Waves is the disturbance in water or a medium.
Okay, good answer, thank you. So waves are the, thank you, disturbance in a medium, okay? Not just water, we can create disturbance in any medium. So when I was striking the tuning fork was? What? Vibrate. So even if I did this and if you are able to hear something, what do you see? You did this in the physics lab, right?
Yes.
You were able to hear a sound. So the sound is what? Sound is wave. So it is the waves are the disturbance in the medium. So in sound we are creating disturbance in air. Okay. So it can be in any medium like water or air. So sound is produced when we disturb the air. Ripples are produced when you disturb the water. So those disturbances are called as waves. Okay. So I will show you the slide now. Okay. So waves. So waves is a disturbance that moves the energy from one place to another without permanently moving the material as it travels through. The second sentence, I will show you another demonstration. You will understand. Okay. So right now, just know that it is a disturbance that moves the energy. Okay. Not the particle, but the energy. I will explain that later on. Now, waves can be classified into two things. One is electromagnetic waves, and another is mechanical waves. Now, you have learned about electromagnetism in chapter 4. So, think what can be electromagnetic waves. Electromagnetic waves and mechanical waves. And we have learned about mechanical energy, right? So relate that term mechanical here also. So what do you think might be electromagnetic waves? Look at the word. Okay, any volunteer first? Okay, roll number 25. Or can you give me an example of what an electromagnetic wave can be? The hint is the most common thing we learned in our previous chapter.
Waves that
I'm just asking you the example. So the hint is chapter number 5. Chapter 5. That DC motor was chapter number 4. The hint I'm giving you is chapter 5. What was the phenomenon and what was happening in chapter 5? One word only. I'm asking you the example of electromagnetic waves. No, the hint is it's in this class. Something you are able to see in dark. What the heck? Light. Okay, good answer. Thank you. So one of the example of electromagnetic wave is light. Okay. So thank you, please. So light is an example of electromagnetic wave. I will explain this later on. Mechanical wave. What do you mean by mechanical? So when I said the change in energy in DC motor is from electric to mechanical, I give you two examples of mechanical energy, right? So what was happening to DC motor? It was rotating or moving, right? So mechanical means it should move. So can you think of any example of mechanical wave? Yes? Water waves, okay, good answer, water waves. Or sound waves, okay, water or sound. Okay, good answer. So these are okay. Now let's talk about electromagnetic waves first. So electromagnetic waves are those waves that do not require a medium to travel and can move through a vacuum. So light can pass through a vacuum, right? Vacuum means what? Empty, right? There is no air. So light can pass through a vacuum. So anything that can pass through a vacuum that doesn't require any medium, it's called as electromagnetic waves, okay? And other examples can be X-ray, microwaves, right? So anyone has done X-ray in this class? You have done? So you kept your hand something like this, yes? No? So you have done another X-ray? Yes? You did the X-ray for it. So your head was kept at some place, right? So and something was passing through, right? Did you see anything that was passing through? No, right? Because we can't see the X-rays, okay? X-rays are the waves that we cannot see. So other than light waves, any waves that we cannot see, those are called as electromagnetic waves, okay? So if you are asked to give example of electromagnetic waves, you can say light waves, X-rays, or even microwave. Anyone uses microwave at their house? You use? So when you keep the food inside the the microwave, do you see anything inside? No, right? So anything that we cannot see, those are the example of. That is a microwave, and microwave is an example of electromagnetic waves. Clear? That much you need to know. Now coming to mechanical waves, it is just the opposite of electromagnetic waves. Okay? So waves that require a medium to pass through. Water waves, it required water, right? Sound, it required air. So whatever waves that require a medium to pass through or to travel, it is called as mechanical waves. Okay? Here an example can be sound waves and water waves. Clear with that? Yes. So waves, two types of wave, electromagnetic, mechanical. This one doesn't require any medium. This requires a medium. Now we will delve further into what are different types of mechanical wave, and for that I have another demonstration. I need to volunteer. Anyone from this row? Can you come? Okay, so this is a wire. Can you hold this end? Now I will try to create a wave here, okay? And observe what is happening. Can you hold still? I will be the one moving. Can you also shake now? No, not that. Did you observe? Yes, this much only. Okay, are you able to observe? The last group, were you able to observe? Yes, sir. If not, I have simulation for this one also. Okay, so this is a PET simulation. This is a range. There is a fixed end here. Now I will try to move this range. Okay? This instrument. Then observe what is happening. Okay, there will be discussion after this. So please observe what was happening. Clear? Were you able to observe? Yes? Everyone clear? Do you need to show it again? No? Okay. And another one, I couldn't bring the slinky spring because the lab is using that. So I will show you this one, okay? This is another different type of wave. I will play it. Observe what is happening, okay? Everyone? Yes? So this is what is happening in reality if you like deep further, but okay, I will show you another video. This one, okay? The second type of wave is this one, okay? This is what would have happened if I used the slinky, okay? The spin. So are you able to see? And were you able to see that simulation and the demonstration?
Yes, sir.
Yes? Okay. So now what I want you all to do is, it's called the round table discussion. So please again discuss in your groups. So what you need to do is, one member will take a piece of paper and you write the difference between the two waves you saw, okay? How was it different? What different thing you saw? Just one word or one sentence, and then you pass the paper to your friends. You can discuss together also. So after you are done, I will ask anyone from the group to present your writing. Okay? I'll give you around 3 minutes to discuss. Are you all clear with my instruction? Yes? Have you done this round table before? Round table discussion, yes? If you have doubt, please ask me. Forgot what was happening. I can explain again. We'll discuss together, don't worry. If you have written nothing also, it's okay. We will discuss together. So first of all, any volunteer? Any volunteer from any group? Do you want to? Okay.
So what I observed in the first,
Okay, wait, first is one and I will write two. The first one is,
the first one was that the vibration was much slower compared to the second experiment, and I can also observe that there were that the more we shake the rope, we can see more waves.
more waves, okay, good, thank you. So this was slower, right?
Yes, sir.
Slower. And this was faster, okay, thank you. Is it?
One more.
And this was moving more
Multiple waves.
multiple waves here, okay. Multiple and fewer, okay. I will write fewer waves. Okay, good answer, thank you. Any different answer? Last group is
On the first demonstration, the waves goes up and down.
up and down, okay. Up and down. And what about in the second case?
Goes back and forth.
Back and forth, okay, good answer, good observation, thank you. Anything different you see again? Any different answer? Any different answer this group? Anything different? No? So in this case, what did this reminded you of? So it was going like this, right? Alternating current. This was similar to alternating current, right? So can you relate anything? Now this is how the figure will look like of this wave, okay? Now can you tell me anything? It is going up and down, goes slower, it had multiple. I will tell you what this is, okay? I cannot tell you right now because it will spoil our next lesson. So You see multiple things right here. I will tell you what that thing is, okay? Now anything else you see? Alternating, okay. Good guess? Yes? We will get back to this. So and this one I may not be able to even draw the graph also, but it was going like this, right? It was stretching and coming closer, right? So do you know what would be the name of this wave? Both these waves are mechanical waves, okay? There are two different types of mechanical waves. And I already showed you. One was this, and this kind of wave is known as no. Any guesses? It's going like this. I cannot give it more hint. So it starts with letter T. Maybe you have learned in maths, in geometry, that word. No, it might be a new word, so it is called as transverse wave, okay? Transverse wave. And this kind of wave is called as, if you can't look, you already saw? Okay. So this kind of wave is known as longitudinal because it is going up and down only, okay? Side by side. So it is called as longitudinal wave. Now we will see some more differences. So this was called as transverse wave, right? When I moved the wire, it was going like this, just like the alternating current. So what can you see is that it is the type of the wave in which the particle moves perpendicular to the direction of wave. What is the direction of wave? How is the wave moving? Not this one. So wave was moving, if this is like this, wave is moving in which direction? Right, right? So now we are saying these are the particles. So the particle is moving up and down. So this is going to the right and particle is moving up and down. So this becomes what? 90 degrees called as in math perpendicular, okay? So that is what it is saying. The particle moves perpendicular to the direction of wave. Clear? And they have the highest point and the lowest point, right? I was wanting this answer from you all, but you couldn't guess it. So you can see this is the highest point that the particle can reach, right? After this, it is going down, right? So this is the highest point and this is the lowest point. So in a transverse wave, we can see highest point and a lowest point. There is a specific term for all these points. We will learn it in next class, okay? And lastly, electromagnetic waves are transverse wave. So light wave is a what are the examples of electromagnetic waves? Light. So light is an example of transverse wave, okay? So if you want to give an example of transverse wave, you can say light, X-ray, and microwave. Any other rays, you know? The thing that causes sunburn, UV rays. Okay, so any rays which we cannot see, we can call it as transverse wave, okay, or electromagnetic waves. Clear? Yes. Now let's look at longitudinal waves. So this was what was happening, right? So how is it different from mechanical wave? What can you tell about the particle? I said particle is perpendicular to the direction, right? So longitudinal wave, it is a type of wave in which particle in the medium moves parallel to the direction in which the wave is going. So wave is going like this and the particle is also moving like this, right? So longitudinal wave is parallel, transverse wave is perpendicular, right? Clear? So particles vibrate back and forth. So like Tanin said, back and forth, right? So the main difference is this is up and down, this is back and forth. So particle moves back and forth in the same direction as wave. Clear? And they have the region where particles are close together, right? As you can see in this GIF, this where the particles are closer and where the particles are separated, right? Region where the particles are spread out and coming closer, right? So in a spring, if you compress the spring, it comes closer. If you spread out, it goes further, right? So longitudinal waves, they have a region where particles are closer together. We have a name for that, and where the particles are further apart. Clear? So those waves are called as longitudinal waves. And some examples can be sound wave. So sound wave is an example of longitudinal wave. Okay. And earthquake. So what is an earthquake? So there is a disturbance in the surface, right? The two plates collide and you create a vibration, and that vibration is the earthquake. So earthquake can be also an example of longitudinal waves. So are you all clear? Yes. So any question? Okay, so we are at the end of the period. So this is it. So if you have any questions, you can ask me tomorrow, okay? Thank you for listening.
Thank you, sir.